Hey class, during today's lesson we're going to learn how are chemical and mechanical weathering related, and the objective for today's lesson is to compare and contrast mechanical and chemical weathering. So take some time to copy this input into your notebook. Feel free to pause here, and once you're done copying this down, move on to the next slide. So you unpause. Okay, so let's recall from our last lesson on soil formation, what is weathering? You don't need to copy this down because this should already be in your notes from your soil formation notes. So weathering is when an object wears away or changes its appearance by long exposure to the air. So remember, there are two types of weathering. We didn't learn about this last class, but we will today: mechanical or physical, and chemical. So let's start with what mechanical/physical weathering is. This is when a rock breaks down into smaller and smaller pieces, but it does not change the chemical composition. So it's very important to know, it does not change the chemical composition. And there are three reasons that mechanical or physical weathering would occur. The first is frost wedging, the second is unloading and exfoliation, and the third is biological activity. And we will dive into these three reasons in the next few slides. So we're going to start with frost wedging. Frost wedging is when water gets into the cracks of a rock and then that water freezes and expands, and this causes the rocks to break apart. So there's a diagram on this slide that shows you exactly what that just described. So water is filling in this crack, and so when it freezes, water expands, and this causes the rock to break. So that is one form of mechanical or physical weathering. Unloading and exfoliation. So some rocks form underneath the ground under a lot of pressure. And so when this pressure is released, the rocks will expand and then are brought up to the surface. So this is also another form of mechanical or physical weathering. The last form of mechanical or physical weathering that we're going to talk about is biological activity. So remember, back from our very first few lessons, bio is a prefix that means living. So this is when living organisms break apart rocks into smaller pieces. So an example of this is when roots from a tree trunk will grow into rocks and break them apart, which can be seen in this picture right here. So now that we've learned about physical or mechanical weathering, we're going to learn about chemical weathering. So chemical weathering, in contrast with mechanical or physical weathering, changes the chemical composition of rocks and turns it into a new compound. So this happens when water mixes with minerals. So this distinction is really important to know. When water mixes with minerals, it's really easy to get this confused with physical or mechanical because water is involved in frost wedging. But in frost wedging, this doesn't mix with any minerals. It just simply fills into a crack, expands, and breaks the rock. But in this example, water mixes with the minerals and turns it into a whole new chemical composition. So make sure that you're reminding yourself of that when you're distinguishing chemical weathering and mechanical or physical weathering. So just to review, key differences between mechanical and chemical weathering. So during mechanical weathering, the chemical composition of a rock does not change. So each piece has the same chemical composition and characteristics of the original rock. And then during chemical weathering, rock is transformed into one or more compounds. So now that we've learned the difference between mechanical or chemical weathering, we're going to do a check for understanding. So that's what CFU stands for. And we're just going to go through these 8 examples, and you're going to be able to distinguish between each of them. So the mineral iron rusting inside a rock, is this mechanical or chemical? This is chemical. So iron is rusting, so its chemical composition is changing within the rock. So the rock's chemical composition changes, and therefore it is a form of chemical weathering. A rock cracking after a big ice storm. Is this mechanical or chemical? If you said mechanical, you're right. So this is an example of our frost wedging, back from this example. So that is mechanical weathering. A limestone rock developing holes from rainwater. So let's think about this. Is this mechanical or chemical? So this example is actually chemical. So the water is mixing with the minerals and then is forming a hole. So this example is chemical. Blowing sand at a back wearing down a wooden bench. So this example is mechanical. Okay, tree roots cracking a sidewalk. This is also mechanical. So this is just an example of a biological activity. An iron nail that has been left outside rusting. This is a form of chemical. Salt or halite in a rock being dissolved by water. That is chemical. And then acid precipitation is also a form of chemical weathering. So now that we've gone through that check for understanding, we're going to do a little more practice. So this Chinese statue was built in 618 AD. Over the years, the face of the statue has been weathered by acid rain, which has dissolved parts of the statue and given the Buddha a blackened nose. Is this mechanical or chemical? If you said chemical, you are correct. So what happens is the acid rain will dissolve the rock. So it's mixing with the water and changing the chemical composition, and therefore it is chemical weathering. What about this? Mechanical or chemical? This arch of rock in the Grand Canyon is made from sedimentary rock that has been worn away by the wind blowing on it for thousands of years. If you said mechanical, that is correct. So the chemical composition of the rock does not change. It really is still the same, there's just one big hole in it. Okay, this rock might look foliated, but those are not foliation lines. The cracks in this rock are caused from where water entered the rock and froze, cracking the rock apart into pieces. Is this mechanical or chemical? This example is mechanical. So this is an example of frost wedging, and therefore it is mechanical weathering. All right, there is iron inside this rock. When iron is left outside and exposed to rain and oxygen, it will often rust like this rock did. Mechanical or chemical? This is chemical weathering. So what happens is the iron is changing the composition of the rock. All right, this gravestone is made out of the sedimentary rock limestone. Over 200 years, the animal on top of this grave has been dissolved away by the rain. Mechanical or chemical? So this is chemical. This is when the water is mixing with the minerals, which is then causing this animal that was on top of the grave to go away. Right, what about this? This is a 400-year-old bonsai tree. This tree's roots and trunk have pushed through the rock on top of it and cracked the rock into pieces. Is this mechanical or chemical? So this is mechanical. This is when biological activity, so the roots are breaking into the rock. So copy this down. What factors impact weathering? So there are four things that we will say impact weathering. Mechanical weathering will speed up chemical weathering. So by that we mean that if, for example, a tree's roots have broken into a rock, this allows chemical weathering to take action because there's more space for it to enter. Same with frost wedging, where when the water expands and then causes cracks, then more room for chemical weathering can occur. All right, so rock's chemical composition to begin with also impacts weathering. So there are certain types of rocks that are more prone to being weathered compared to others. Then temperature and moisture, so those also impact weathering. And then lastly, climate. So how many times water will freeze then thaw is determined by climate too. So for example, if it's really cold, then you're probably going to get more instances of frost wedging, which is a form of mechanical weathering. But if it's a lot warmer, you might experience different types of weathering. So lastly, take some time to copy this output chart into your output.